Alright, you guys, I got another example for you. This is an example about work done by a variable force. And AP likes to ask lots of questions like these, so I thought I'd show a basics example to just give you an idea what they look like. So we've got a 1,500 kilogram car accelerating from rest, and below we have a graph showing the force versus displacement, net force versus displacement acting on the car as it travels from a starting position of 0 to 200 meters. And then we got to find the speed using this information. Okay, so remember that energy initial of any system plus whatever work is done equals energy final. And this just comes from conservation of energy and the relationship between energy and work, because work is defined as a change in energy. Since the car is at rest initially, the initial energy is 0 joules. So we say 0 joules plus the work equals your energy final. Now, since we're just talking about a car on flat ground, the energy final is going to be just kinetic energy. So work equals, K final. Okay, so now work has two definitions, and one of the definitions is FD cosine theta, which we've been talking about. The other definition is work is equal to the integral of F times S ds, and that just means the work along, or the force, parallel to the displacement. That's why you get the sub S on the F. And then the bounds of our integral are our initial displacement point and our final displacement point. And so in this situation, our work is going to be equal to the area under this curve from 0 to 200. So we could write it like this: work equals 0 to 200 of F net times, in this case it's just the x, so it's dx. And that's going to equal 1/2 mv squared, because that's the K final. And from that we can find V final. So we just find the area. Since this is a triangle, we just take the area of the triangle, which is just going to be a half of the height, which is 10,000 newtons, times the base here, which is 200 meters. And that equals 1,000,000 joules. And we set that equal to 1/2 mv squared, V final squared. So to solve for it, we take 2 times 1,000,000 over the mass, which is 1,500. Take the square root, and we'll get V final. And V final is 37 meters per second, or thereabouts.